Welcome to the seventh and final part of this Power Query challenge. In this exercise, you're going to put together everything you've learnt so far, as well as I've included one extra complication. The complication is that the file that you're importing from this internal system never has a consistent number of header rows above the data that we're interested in. In this example that you can see, there are 8 rows above the data that we actually need. But I've also given you a version of the table that has 12 headers above the data that we need. So your query needs to be able to decide exactly where that first useful header line is and remove everything above it. In addition, you'll need to do all of the usual rearrangement of the data and data transformations, and the query output you're looking for is to produce a report of sales by quarter and by category in this format. Once again, have a go yourself before looking at the solution, and if you need to refer to any of the videos from Power Query Fundamentals course, please feel free to do so. Let's have a go at solving this final Power Query challenge, where we're asked to solve this problem with a dynamic number of useless header rows above our actual data. So this really represents an interesting problem-solving task where we have to think a bit differently from what we've done before in Power Query. The easiest way I can think of doing this, which isn't the most efficient, is to use a conditional column to identify which row the word metric appears in. Obviously there's a limitation to this, which is that the metric column must always be the first column in this report. So adding the conditional column here, we're saying essentially, does this first column, query name, equal metric? And we can see that that is true for the header row and not below it. All of the values in this case are null, which means we can fill down values, creating a true in every row except the ones above. Now we can filter the null values from that column and remove that header column. This then leaves us with the data set to manipulate. I'll come back to the rest of the manipulations in a second, but I want to show you a slightly more efficient way of achieving that same step. And I've got that saved in this method2 query here. So we've got this table here with the source data, and I want to remove the first n and 8 in this case number of rows. Normally you would go to remove rows, remove top rows, and define the actual number you want to remove. But instead I want to keep that dynamic. So using the table.removeFirstN function, instead of entering a number as the second argument, I've entered this condition, which says each value in the query name column is different to metric. And so what it's doing is removing all the rows that don't equal metric until it finds one that does. Once it's found one, it stops operating and saves all the rest of the rows. This is an interesting functionality that you can see in the documentation for list.removeFirstN or table.removeFirstN or table.skip even. We can see that you have the list itself passed as the first argument and then an optional count or condition as a list. Usually we're used to using that count. But we can see in this example further down that if we pass it a list of 5 numbers and then pass a condition that says each value must be greater than 3, it removes the first n values where that condition is true. So it will remove 5, it will remove 4, 2 then breaks the condition, and so it keeps everything else. So this is a far more efficient way of solving the same problem. We're then free to promote the headers, change the types, remove that null row from the top. We can fill sales and margin down the left-hand side, and then filter out the margin values which we don't need. Now we're only interested in the category and the dates, so we can remove metric and store. And then really it's just a case of applying the same date logic as we have in the previous exercises to leave us with a category summary by quarter. The big challenge here was really to deal with those dynamic number of header rows. But it really does show that Power Query is all about problem solving. Every data set you come across is going to be slightly different. And so you're always going to have new but interesting ways to solve each problem that you come across. That brings us to the end of this 7-part Power Query challenge. I hope this has given you an opportunity to either practice your skills and develop those problem-solving abilities, or even just to explore the functionality of Power Query and see just how much time it can save you in automating all of those data transformations that you do day to day. If there's some concepts in here that you weren't sure about and you want to brush up on your skills, then check out our Power Query Fundamentals course, where we go through all of the key concepts in a structured course where you can practice those skills. We'll go through everything from splitting columns to merging tables, joining identical files, and we've got a chapter dedicated to dealing with errors. Remember, Power Query is going to help you not only in Excel, but with Power BI if you choose to move to that BI and data viz tool later on. In my opinion, Power Query is the most underrated BI tool out there, especially as it's integrated within Microsoft Excel, which is so heavily used by analysts today.